Um, okay, so my presentation today was kind of an addendum to the presentation I gave last time on the coastal change. So what I wanted to do was uh, basically we observed last time with the coastal change notebook the ability to kind of extract a coastline. So we did a couple of things. We talked a little bit about Dask. We used band math to identify water and not water, and then we extracted the actual coastlines as a vector file from that. And we saw that when we went through our data set and we extracted the coastline in the area off of like near Tassinere, like St. Louis area in Senegal, um, that there had been some kind of dramatic change in the barrier island sandbars around that area. And so one thing that might be useful if you were to, kind of putting together either a presentation or trying to just kind of get a better understanding of what is going on in the area is to actually generate some pictures uh, for the area. And so there's a couple of ways to do this uh, on the sandbox. So uh, one way is to use in the DE Africa plotting kind of package here. There's a function called RGB, and RGB is nice because it's just like really simple. You do RGB, you give it your data set, and it automatically takes the red, green, and blue. And it kind of has some nice sane defaults to generate just an image plot of what you're looking at for a given time slice. But that's not really that great when I wanted to kind of automatically generate um, look for change over time in a given area. And sometimes I might not really understand that there is change over time. And we have eyes, and they're very useful for kind of digesting a lot of information at once. So there's actually a whole app that's app in quotations because it's just another notebook, but it's a kind of a more interactive notebook, and that is the change film strips stuff. And so there's a script here in the scripts folder, right, that does this. And this script basically handles just this one notebook, right? So it's actually kind of an intensive thing, and but it's actually really handy and it's really interactive and it's kind of fun. Um, so we have so there's a lot of background here. We're going to actually, what's really I like about this example notebook is that it uses the full extent of the Landsat data to actually get an understanding, for some of these really long time scale changes that may be going on um, in an area you want to monitor. And with the continuity from Landsat 5 to Landsat 8, right, we can basically go back to the 80s to see what may be happening. That doesn't necessarily mean we'll always have like good data. I know the visit times, like kind of going at beyond that, kind of change. Um, we talked about the scan line stuff with the uh, scan line errors last time. I think I might have misattributed that, but um, but if anybody has any questions, where I kind of wanted to actually do a question session at the end of this. So I'm going to keep this brief. So the idea is that we're basically going to generate pictures for each time step and then actually create this change heat map. So we actually don't have to load that much here, right? If we want to export GeoTIFFs, we can do that at the end, but it's really just this film strip app that you import into a notebook. And then there's a few parameters that you have to put in that are required. So the name, right, would be, for instance, I might just call this, uh, you know, coast coastal change or something. I'm not really sure, right? And this is just going to be the names of the file. So if there's some way you want to organize this, the time range. So this is, you know, from when to when do we want to generate this film strip, and then finally our time step. And I've changed most of these. The optional parameters are actually quite handy. And remember last time we were only interested in high tide. We set, the idea of a percentile of what tide to filter by, to filter our data set. This will actually take care of, we can put the same parameters in and it will take care of the filtering for us. And so we can do basically the upper half. So they're from the 50 percentile to the 100 percentile is what we're going to consider high tide, because we are looking at a coastal area and that might change some things. It might be interested to look at the low tide as well, or maybe all tides. One advantage of this is it gives us some consistency of where the coastline is over many, many years. And it gives us consistency with our last analysis. Um, but another side benefit is that it really narrows down the amount of data we're having to process, as well. Then max resolution is the standard Landsat resolution. We have 30 meter by 30 meter pixels. And then with the max cloud, this is basically saying I want to throw out all images, all captures that are going to be more than 50% cloud. And that's used with the Q&A band. Then this by default is off. This is the same Landsat 7 scanline error, scanline correction malfunction that took. And so when you have this set to um, true or false, it's basically determining whether Landsat 7 data will be included. And with the scanline error, the capture of the satellite actually zigzags back and forth because it doesn't have the compensation for the forward motion of the satellite. So there's like some there's some missing data in the capture. We actually don't mind that in this case because we are going to be taking this app automatically takes geomedians, and so the actual differences in the captures will actually kind of all even out. And then the size limit, this is just basically saying we don't want to capture more than 100 kilometers, and this is just a sane kind of thing, especially on the notebook. I wouldn't capture more than 100 square kilometers. All right, so the first step is to import, and then we need to, I think I like these parameters. I want to do this every 3 years, so this is actually kind of a small time step for this amount of data, right? We're going from 84 to 2020. One thing to make sure when you're doing this is make sure you have kind of recent data. So always go and check the up at the top of the notebooks. You can check the products that are being used, and you can just click on them. It'll take you to the Explorer, right? And we can see here for Landsat 8, for the USGS scenes, surface reflectance scenes, it's actually only present in a few designated areas, but it is quite extensive. For Landsat 8, this is going from 2013 to 2020, and so they're kind of being kept up to date. And this is fine because I'm going to plan to look at this area here. So I am within the area I want to look at. It's just a good sanity check, or if you're having trouble loading data, you might want to check that. And so then I need to run the app. So I just basically call the function to run the app, right? And I'm just feeding in each one of the parameters we set previously. And this will actually pop up an interactive map. And it's actually centered on the example given above, but I can just navigate to the area that I would like to kind of inspect, somewhere around here. And so this is the area we were looking at last time with this kind of moving barrier island or sandbars. And I think I want to look at kind of an area you can actually draw an abstract polygon as well, but I'm just going to use the square tool. And I think like something from, like here to, I think, there looks good. And then you go up in the top right corner and you just hit done. So this is kind of very nice and neat. And then it'll start down here with starting the analysis. And so if I already have my Dask plugin set up here with looking at 887, it will actually, I can see a progress bar, but I can also just click through to this and see a status page, right? And so right now, I can see the progress of specific tasks along the bottom. I can see a total number of tasks to be conducted that are kind of like in the queue over here on the bottom left. And then this is the task stream. So I have 2 cores going, and I can see what each one of these cores is doing at a time. And when I actually hover over any given individual task, I can see how long it took. So what just concluded, and so sometimes there's kind of multi stages into some of the scripts that we're running. And so what just happened is it basically just filtered everything for how many clouds it had, and now it's actually loading the RGB images based on what it filtered, right? And so we can actually kind of see that out down here, where we have this data cube load red, data cube load blue, and data cube load green down here. We can also see we have a geomedian to create, and there's some rechunking that has to happen. And we can actually see that this was a merge that happened, and that step itself took 11 seconds, right? So that was a big step to re-merge all of the chunks. And you may be asking what chunks. You can go up to this graph page, and this graph page will actually give you an idea of the flow of data that is actually going to be going on here. And we can actually zoom into this, and we can see that each one of these is, has multiple parts to it, right? That there's like kind of like 4 different parts here. And the color of each one of these nodes kind of tells us where in the process it is. If it's blue, it's been completely completed. If it's red, it's loaded the stuff up into memory. And if it's green, it's currently being processed. So we can see how it's actually going through each one of these, and so it's loading all of the raw captures, and that these are being reduced down into our final actual images here, right? So we can see we're going to have 1, 2, 3, 4, 5, 6, 7, and then this eighth one, I'm going to presume is going to be the change map, and that kind of makes sense based on what we were looking at. And so let's go back to the status and see where we're kind of at here. And I think we just concluded as I popped over. So actually, yeah. So let's go ahead and look at what we have here. And so I'm going to change back to the file. And indeed, we did just complete, and we generated this nice film strip, right? And what's really neat about this is that even though it looks like in the older data there may be some trouble with cloud pollution, but then we actually have some really nice clear data here. And we have what looks like to be kind of a complete barrier, shoreline, coastline here. And then um, basically maybe some thinning and then some opening, right? And then looks like some migration where this hole is kind of actually almost migrating down the coastline is almost what it looks like. Our change map is probably being thrown off of this. So if I was to run this again, I would probably go back and maybe change the dates I was running this for to try to avoid some of this problematic data. And that may be because there's not as many captures in those years, and that would actually require me to kind of go in and dive into the data. But this is a pretty decent result um, for a first shot. Um, and then what I can do, oops, what I can do next is I can actually export these as GeoTIFFs and actually take a look at it. So, but we've gone over that in previous things. So, if anybody has an area they want to look at, or if they have any questions about um, what to do, how to use it, that kind of thing. Um, yeah, that's all I have for today.
Thank you, Brian, for this great presentation. I think some of the users, some of the participants in the group would like to give an example of an area they would like to see, and this is your time.
Mm-hmm. I think we were looking at a place off of the coast of Tanzania last time, right? I'm trying to remember. Were we? I think it was somewhere in here, but I'm not. Maybe I think it was in here, but I'm not really sure. And we would also have to check the area. I was trying to remember the example from last time. But if anybody has any ideas, I'd be happy to take them, or any questions.
Yeah, how about Brian? You try the coast of Kenya on that chart.
Okay. Any place do you think there's going to be a change on the coast of Kenya?
It will be interesting.
It would, though, the whole coast will be interesting. So we can.
Yep.
So one thing to keep in mind when you actually kind of run the notebook is that it's, you got to keep in mind, like, kind of just how much area you're doing. So I know Kenya, I'm not sure from space, but it's somewhere in here, right? Like where the coast begins and ends. Let's see, we're gonna need to rerun the app to do this. So it'll recenter us where we were previously. Do you have an area of particular interest? Maybe. Let's be able to see, like, maybe Mombasa or Nairobi or something from space, but I don't know. What does this look like? An interesting area? I think I'm a little too far south.
Yep,
All
this
right,
one will work. There.
Okay. There? Okay. All right. We can actually just draw maybe sort of a more slanted polygon here. Okay. And then done. Come on.
I think it could be a big area. Just you could narrow to the small island that you see in between the landmass, make your work a little bit easier. Yep, the small that area.
Yeah, this shouldn't be too bad because we're at kind of a low resolution. Whoops, cancel. Actually, I kind of want to take a look at this port area. Let's go up here. Just do this. I'm wondering if I'm having trouble loading data. So usually it more quickly responds. So
there we go.
oh, one more time. I think this actually may be due to the issue I was talking about earlier. You have to make sure. I mean, we should be right here, so
yeah,
it
it's
should
covered.
be within our.
Yep.
Should be covered. Warning that. Oh, too big. That's why it's yelling at me.
That's why I mentioned the small island. I have a feeling it was big.
Yeah.
Yep. So what has happened is that some guys in the shoreline have done some dredging to create ways for the ship.
Okay. This may still be too large. Let's cancel this.
The small part around the island will be enough for you.
Okay.
A tiny part. Yeah.
Uh,
Yeah.
like so.
That's David's favorite holiday spot, David Ongu.
Okay. It still may take a while to load here. There it goes.
Yeah.
Uh-oh. Resolution. No CRS data was provided. Okay. So let's go to
So this could be related to the question of Tanzania, where they had some issues with the Landsat 7.
Yeah.
Mm.
Yeah, it could be. And this is kind of an interesting thing that there may be missing data here. So that's what I'm going to try to figure out real quick. So what I did was I went up here and I changed the dates here in order to, I isolated it. And just to be sure, this should just be Landsat 8 now. But I also turned I think there should be some Landsat 7 here also with the, I'm trying a couple of things at once just in the interest of time. So I'm going to run the app again. Okay. Do this. Go from here. Whoops. Clear all. Go from here. Here. You know, live demos never go completely smoothly. All right. But now I'm beginning to wonder if there was some issue with Landsat 8 in this area. Because as I recall, the area last time was bordering on 2013 to 2012, which would mean, yeah, okay, so if so no CRS data is fine. Fine, okay. So, so I believe the error is that we don't have data, that it's still asking for Landsat 5 data for this area. And there may not be Landsat 5 data. So if we go here, no, there should be. That's strange. Okay. But it's specifically yelling at me about Landsat 5. So then we would go into the scripts here. Load data from these Landsats. I can actually just comment this out. I can hit save. And then what I can do is I can go back here. And let's say I didn't want to include Landsat 5 into this. So this is getting a little bit more in-depth and a little bit more technical. But what you need to then do in order to make sure the changes I just made from that, right, I need to restart the kernel, basically. So so that way I'm starting everything afresh. Kernel's been restarted now. And just to confirm that, this should be a 1. Yep, okay. Because this is the first cell I'm running now. There are my parameters. Okay, let's go back. Now let's see if I can remember exactly where I was.
There you are.
There we go. Yeah, and then
you could just take a small portion there.
You think this is still too large? Let's see.
I'm crossing my fingers.
Yep. Right now, it's not. It's actually not the size that's tripping us up. It's actually data availability. So that CRS error is actually kind of misleading. And I would lobby for it to get it changed. But the idea is that what it first does is it checks to see if there's like a CRS for the data set that's there. But if the data set doesn't exist, it won't necessarily it throws that error first. So maybe I did not. There we go. I forgot to hit done. So SLC 7 off. So yeah. I don't know. So actually, I'll have to take this up. So this seems to be a recurring problem in this area. That's strange.
It's only an issue with the
I can
Landsat 7.
create-
Once you remove the comment on this one as well, the Landsat 8 should work.
Interesting. Okay, then I will dive into this a little bit more because I thought it was something just attributed just to that. And
Now it will work very well.
let's hope. Restart.
Otherwise, from people who've joined us, any question for Brian? Brian was presenting on change film strips. So try to keep you guys busy as we wait for the results. Stella Mtai, thank you for joining us. Any progress from your side?
Hi, Mobile. I'm fine. I'm still stuck at data part. That's my biggest struggle for now. But when I get through, I will let you know.
Don't worry,
Are you
data
having the
is
similar error?
80%.
Yeah. Maybe it's me who did not understand Brian's presentation in like a sentence or two, because I joined late. Yeah. Sorry.
Oh, so this was supposed to be kind of a follow-on from last week, and the idea was that we observed some coastal change, and that this notebook, this notebook change film strips app, allows you to basically create kind of just many different sections throughout time of the same area, just by selecting an area on the map. But we're actually running into a similar problem that I believe, was it you last time that was running into this same most common CRS thing in this area. It seems to work in the west, but not in the east, which is quite strange to me. And I thought it was attributed to the scanline error, but I'm not so sure now, which is strange. So let's see. Most common CRS. Oh, okay. I see what the problem. Okay, so this let's do Landsat 8 here. Because we don't want to derive it from that. I think the idea is that for some reason there may be missing Landsat. Okay, that makes more sense. And then we'll re-enable Landsat 7 because I actually don't think that save. Whoops, wrong set of tabs. Restart. A little bit of troubleshooting, but this is good. And if you ever get a question like this and you get stuck, you can always email helpdesk at Digital Earth Africa, and somebody like myself or Josh or maybe even Ken or Edward, somebody will, these are good issues to raise, and they may even become issues on the GitHub where we're kind of developing this because, mistakes are made. There's things that are, maybe broken or not working. And so they are good to know about, and you don't really know about it until you try to use it. And they may be working some places and not others. But they should be working like the goal is to have everything working everywhere. So please let us know if you are counting an error.
So thank you, Brian. I think also Edward has a presentation which he can be making as you
go on with it.
Yeah. Thank you so much, Brian, and welcome, Edward, sir.
Okay, thank you, Ken. I have a quick presentation to give. Is that let me share my screen. Okay, so I think we have been having the live sessions every Wednesdays, and through that we're able to actually talk much about the products and things you can actually do with the Digital Africa program, especially when it comes to in relation to Earth observation data. So today's presentation will actually be probably about ways that you can actually get involved within the Digital Africa program. And also, if you want to also work with us on most of the products that you want to develop per the region or maybe per the study areas, some of the process that we actually go through it. So who can actually get involved within the program? Researchers, implementers, developers, GIS analysts, domain experts, decision makers, and communication specialists are everybody who can actually get involved. So you don't actually have to have a GIS or remote sensing background, but anybody. So it depends. All you actually need to have a product that's actually going to solve a problem on the surface of the image, Earth observation can be able to capture it. So if those products or those problems are available, Digital Earth Africa, the team is already there to support you. So you don't actually have to get any background to be part and use the product. But any decision, any problem that satellite imagery can actually capture on the surface of the Earth, you are welcome to bring up something. Then how do you actually get involved? So how do I want to get involved? How do I actually get involved? So normally it's through product development, communications, and the live session, just as you had. So with the product development, if you actually identify a problem that you think that you actually want to use that observation to try it out, you can actually reach out to us. And if there are also products that you have within your organization, you actually use different existing platform to work with, but you want to also migrate those things also to Digital Earth Africa or use the resources available in Digital Earth Africa, that is also welcome. And you can actually go through it and rework it also again. We also have the communication. Maybe you've actually identified a problem or you've seen something, you want to write a blog around it, or you want to communicate with others. You are welcome to do that. And you also have the live session, which we're having currently right now. Please excuse me. Okay. Sorry. So as you can see, these are some of the already existing products that has actually been developed. There's a rapid impact assessment, which is actually found at the Mount Kenya. It was developed from Eric, who is actually based in RCMRD, and he used the product to actually work to see how mapping forest fires can actually be effective. And after that, it was actually published out. And this is also a work that Victor also who also worked with using the water observation from space. So these are all some of the products that actually help people to utilize the platform. And actually, what Victor actually did was to utilize the web mapping services. So he actually didn't use the sandbox, but he utilized the web mapping services into the QGIS, the desktop, that's QGIS, and did a computation from there to develop the product for that particular area. So the question, okay, so I'm interested, I actually want to do something, but how do I actually get involved? Do I actually have to build some complicated algorithms to work with it? No. So the team actually provides a backend support to come and help you. So if you're a domain expert or you're a communicator or you don't have much knowledge in how to, you can actually bring up a product or a use case for a particular region in which you actually want to work with. And you can reach out to Ken or I, Edward, so that you can actually go through those use cases. Then after you've gone through and identified the objectives, there's going to be a development team. Within the development team, you have a developer a geospatial experts, and also a lot analysts. We have all these various kinds of team available in which you actually let them all of them come together. So probably there will be a product that you like to develop, but someone from the live session has expert knowledge around it. We can let him also come and contribute so that at the end of the day, we can actually develop a product that will actually make it work. Then from then, we actually go through the data sets available, the work you want to actually work. So for instance, what Brian make presentation on currently, we have to go through the data sets that we have to see whether they're actually available or not. And if they are not, can we actually incorporate other products available? Then that's also something that we do. Then if it involves much complicated algorithm, we actually also have to build a notebook. So depending on your expertise, you don't actually have to know coding because there's already a team that you have assembled together who will actually help you to develop those notebooks together. So if the algorithm is already there, you just pick it up and modify it. But if it's a new algorithm, the team is also available. Then you get the results, we will discuss it with you. Then if possible, we can publish it out on the blog. So currently, if you go to the Digital Health Africa's website at the blog sessions, you actually see the use cases that have actually been ongoing. Ken will share the link. You actually see the use cases that's actually ongoing within the platform and how people are actually utilizing the platform. So this is what something I wanted to take the team, everybody through it, and so that you naturally know how the process goes through if you actually want to engage and start developing use cases and products within the specific area and region. So thank you very much. Any question and discussions?
Thank you, Edward, for this great presentation. Today people are a little bit quiet, but I know they are thinking about some ideas for you and for us. And possibly they can give us also ideas on what they'd like for us to discuss next week.
While you're doing that, I can share my screen. I did get it into work. You would like, let's see. So I guess for everybody's kind of education, so this is what I was talking about at first checks to see if there's a CRS here. And it was using Landsat 5 to actually check that, but because I removed the Landsat 5 earlier, it was causing the issue. But the real issue is that I don't believe Landsat 5 maybe goes back that far in this area, and I would have to double check that with the Explorer thing. So it was that we were lacking data. So I had to just manually set at what point in time to check for the coordinate reference system. And that was really the issue. And then once we did that, we were able to process this area and actually generate this nice film strip here. It does, I'm not totally sure. You can definitely see the development of the city over time, from 2000 to today. But I'm not, we might have to write this out. But yeah, yes. So I'm not sure. I'm not sure what change we were hoping to see, but yeah, pretty sure though. Anyways,
Brian, this is very, very nice. Also, based on your knowledge, this is like a picture of different years, and maybe at some point.
right. So
yep.
Yeah. So this is I set it to go from 2000 to 2020. Yep. And we see that we don't have many collections in 2020, and we got some clouds there. But yeah.
Yep. And that is fairly accurate because that area is very cloudy. That was the first why we wanted to look at it. Then as a maybe a little bit curious user would be, is it possible to generate a GIF animation of the area of this?
Yes, you could. So once you're in this, so if we go back to the real world examples folder here, so this is, we can first look at, so like it automatically generates this in like higher resolution if you wanted to download this.
Mhm.
And you can kind of, so if you wanted to get a closer look, but then down here in the second part of the notebook, right, we're actually generating TIFFs, but you could also have this, for instance, export multiple PNGs and stuff like that. And also you could actually take some of the cells and with some small modifications in some of the other notebooks where we generate PNGs and stuff like that, put
Hmm.
those cells into this notebook and use that to generate a PNG. So you would kind of just be looping over each one of. There's some nice tools on here that where you would just loop over each picture and then put it all into the same file as a GIF. So, yep.
Yep. Thank you so much, Brian. This is very informative
Yeah, no
for
problem.
us. Yep. So, dear participants, any question for Brian? Ellen Magero, please.
Thank you very much, Brian and Edward, for your presentation. So my question is, I'm just curious, will you be able to see the rising sea level using this notebook? Like if it's, and like when the sea level rises and it encroaches into the land, is it able to be captured with this?
I would say that
Hmm.
erosion due to the sea level rise. Keep in mind that this notebook uses Landsat, right? And so
Yeah.
each pixel is 30 meters by 30 meters. So, you know, if you're familiar with baseball, we're talking about a baseball diamond, right? Is kind of
Okay.
the size of the changes we're going to observe. And that's actually quite a lot of beach, right? Like if you were thinking about any sort of sea level rise, right now, if we're talking about sea level rise on the order of a few feet or, you know, half a meter or something like that, then it would be hard. It could be potentially hard, depending on the topography of the area, to capture that change. Some areas that are extraordinarily flat, right? This could result in more than a 30-meter swing. In areas that are, you know, have a much more maybe steep beach area, this would probably not capture change in those areas. So areas that are already kind of marshy and have large tidal swings, and that's why filtering by that tide, you know, you would want to see like, is the high tide kind of creeping up in these tidal zones, and that may give you a way to capture it.
Okay.
Overall, I would say I would look at something that would maybe combine some. There's a notebook on the Sandbox that actually looks at extracting the topography based on. We know where the tide is, right, and then we can see where the water goes, and with remote sensing, and therefore we can actually extract what we think the topology of the coast looks like at any time. And so looking at the areas that are maybe flatter, you could kind of maybe zoom into areas that are flatter, but like if you have knowledge of the area, there may be a specific area that you're concerned about, I imagine, right? And so maybe try to target areas that would have these larger changes to illustrate a point. But higher resolution imagery might be necessary for like year-to-year changes, because the changes are much smaller than like the resolution of the satellite in general.
Okay. Okay, thank you for your answer.
Did that make any? I hope hopefully
Yeah,
that
it made sense.
sense.
Yeah, it did. It did.
Okay.
Yeah.
Thank you very much, Ellen, for the question. Any other person? Dr. Kelebugi, how are you today, madam? We can see you at the university. And you're on mute. Yeah. That's Investor Botswana in Gaborone. It happens. Yep. Otherwise, anyone else with a question? Joyce Yundu, how are you?
Hello.
Yes, Stephen Corey.
How are you? Hello, can you
Yes,
hear me?
Stephen, we can hear you.
Oh, okay. Yeah, so I think I asked this question sometimes back. I'm not really a GIS or a developer. I'm just an analyst. And I was looking at doing some farm level crop analytics.
Yes.
And I was wondering how I can be able to access the data sets from DEA. Okay, Edward told me something about OWS, but when I checked it out, to me it was a bit kind of advanced, and I didn't know how I can be able to sets directly. So I don't know. Is there a service? Is there a way in which, or could we set a meeting aside and see how we can be able to help?
Absolutely. We're very open to setting meetings aside and things like that. If you want to go kind of more in depth, but I will say, as far as resources go, there is maps.digitalearth.africa, which has the some of the new data on here. So if you go, this does look kind of intimidating, but I would not necessarily use this. This is still in development, as it notes here. But if you go to the surface reflectance products, the annual GeoMAD is probably the highest resolution because it's based off of Sentinel, and you can just hit add to map. And this would be yearly, right? Because it is annual. But we do have NDVI available here. And so if you wanted to look at yearly change over time, this might be a good resource. The second thing would be there's actually in this real world examples, there's a couple of things I could point you to if we wanted to get into it. But the in the scripts folder, so again, there's actually a whole second app called Crop Health, and it's actually very similar to this one. And so if we go through and we have about 7 minutes left, I think I can do this quite quickly because it's quite similar to this one. So this one has an area that you can change. It can load it up. So you load the data. It's going to take a second. And then you run the app, run Crop Health app. And then what we can actually do here is we can draw a polygon, let's say around like this field here. And potentially, let's say this field here. And we wanted to compare the two. And we can actually plot, this is using, I believe it's using NDVI from when I last checked. It's calculating the NDVI for each of the polygons to actually compare the health of each one of these fields. So might be useful to you as like kind of to poke around to get an idea for using that if you're not a developer or you're kind of new, you just want to get your feet wet. But if you were open to learning, or if you had something really specific that you don't think is being addressed in the notebook, we're all ears for different ways to use the data in the sandbox, and we would like to hear from you.
Okay, I think I'll reach out and discuss more on the details.
Okay.
Because I've been creating some machine learning models through the sandbox.
Okay.
To do yield estimation and also to do some crop type classification. But now I want to scale it up. But of
So
course,
you're
we'll be
talking much
involving
more
a GIS
advanced.
developer. Yes. So
Okay.
of course we'll be involving a GIS developer for the same. So just wanted to understand the mechanics of accessing the data of the DEA and probably on a GIS web map, how I can be able to get the data, do do the analysis, then display the results, probably as an NDVI map, as a trend, or something, just a deliverable. So
Okay.
probably I'll get to Dr. Ken or Edward so that we can discuss about probably how we're able to do that.
Thank you very much, Stephen. And actually, you owed us a presentation at some point of how
Yes,
you
yes.
maybe you can give us next week if you're ready.
Yeah, next week. Yeah, I can do next week.
Thank you so
I
much.
also I also enjoy seeing like work in progresses as well. So like it doesn't have to be
Yeah.
very polished. My demo today was not very polished. You know, it's
Yeah.
all right if there are hiccups. So
Okay, yeah, I'll do one probably on crop type classification or crop phenology or something. Just I'll next week.
Thank
Look
you so
forward
much,
to it.
Stephen. We hope everything will be okay. Otherwise, Amadou Sal, how are you, sir? Any update for us, Amadou?
Hello, everyone. Yeah, it's interesting. I very how I put it. Maybe next week we have some question about the coastal area in Senegal, because before the last session I noted something, but I want to put it on the table to discuss. Thank you.
Sounds good.
Thank you so much, Amadou. Brian and us will be here with you next week, inshallah. Anyone else with a question? Bako, Meme?